So I give my presentation. One moment. Yes.
Yeah, we see it.
Yes. So let's start. Very often in everyday life, in colloquial conversation, in publicity or ad, we meet the opposition, chemical or natural. But it is a really opposition. In this lecture, I want to show selected common beliefs about the harmfulness of the so-called chemical substances and have preventing properties of natural substances. It will show the results of research on this topic, and I will explain which beliefs are true and which are incorrect from the science point of view. At the beginning, because I'm a chemist, at the beginning, chemical points of view. There is no difference between natural and synthetic version of chemicals. Very often people think that synthetic chemicals, it means chemicals made in a lab, are not good for them as their natural equivalent. This is a completely misunderstanding of the basic of chemistry. Chemical molecules have the same properties whether they were created in the laboratory or in living organisms. For example, water. It consists of 3 atoms, 2 hydrogens and 1 oxygen. There are more than thousands of different chemical reactions that will produce water. But water always behaves in exactly the same way, no matter how it was formed, because it always consists of these same 3 atoms. There is no chemist anywhere in the world who can tell how given water was produced. As long as the chemical structure is the same, it doesn't matter whether the chemical was extracted from the plant or synthesized in the laboratory. Since some people believe the difference between chemicals and natural substances, I wanted to investigate how many such people there are, and whether it depends on the level or type education, age, and gender of the respondents. It was hypothesized that younger, better educated people would not believe on unscientific myths. It's also assumed that people with natural science education would choose the correct answer more often than other peoples. I researched 19 myths. In my abstract, I described the result of 7 of them. I note I will not cover all 19 myths today, but I hope to be able to be more than 7 myths. Myth first. All natural substances are healthy. In the first question, a 5-point Likert scale was used. We can see that most of the respondents choose the answer I don't agree with this opinion. Such results seem satisfactory. But if we group the obtained results into 3 categories, yes, no, and I have no opinion, we can notice that only less than 53% of respondents don't agree with this opinion. Almost 38% of the respondents agree with this opinion, and 9% don't know the right answer. I think it is too much. This means that 47% of the respondents forgot or don't know the poison found in nature. In this picture, we see some of the most famous poisons. As the famous Paracelsus, called the father of modern medicine, said, the doesn't make the poison. So, even the plants we eat often contain poisons, but because these are the minimum dose, don't do us harm. So, myth first is not true. Natural substances can be healthy, but they can be also very harmful for us. And there was no correlation between answer to this question and age, gender, level of education, type of education, surveyed people. Correlation with answer to the other question will be discussed at the disease question. So then we let and we see it then. The first question is was the second question. I wanted to check if there is a correlation between the answers to question first and second, and in the questionnaire, these questions weren't close together. In the second question, a 5-point leakage cut was used too. Also, ads often contain an opposition chemical that is harmful and natural that is healthy. Most respondents disagree with the statement that chemical means harmful. If we group obtained results into 3 categories, yes, no, and I have no opinion, we can notice that over 60% of respondents correctly answered this question. However, almost 20% of respondents agree with this thesis, and another 20% have no opinion. During the communism era in Poland, there was a slogan: chemistry feeds, heals, dresses, and builds. In this slide, we see the matchboard with this slogan. Of course, it was slogan, but it is true. Foods, protein, sugar, fats, vitamins, and these are chemical compounds. Medicines, vitamins, dietary supplements, they are also chemical compounds. Cotton, linen, wool, silk, lycra, nylon, fleece, flannel, they are also made of chemical compounds. Slag, lime, cement, we are also talking about chemicals here. So as you can see, the diversion do not occur on the border, natural substances or substances produced in the laboratory, which means chemicals. Both chemicals and natural substances can help or harm us. So myth second is not true. Chemical substance can be healthy, but they can be very harmful. Correlation, no correlation, but Spiderman correlation coefficient between answer to question first and second was 0.44, which is a moderate correlation. This means that if the respondents believed that all natural substances were healthy, they more often also believed that all chemicals were harmful. But it is moderate correlation. It's not strong correlation. Myth third. The third myth ticket whether the answers given in the first and second question were strong beliefs of the respondents. I wanted to see if a different wording of the question would change their opinion. Most respondents agree with this statement. Even though in question first and second, then declared that they don't consider all chemical substances to be harmful and all natural substances as useful. Almost 50% choose herbs as safer. However, herbs aren't always safe. Many herbs have properties that haven't been fully researched. Some interact with the other herbs of medicaments. In this picture, we can see some common herbs in their properties, and on another slide, more examples of herbs and their properties. These are just a few examples how of dangerous herbs can be. Myth 3 is not true. Herbs aren't fully researched, and it often unknown what interaction we may have with other herbs or drugs. They shouldn't be used by pregnant women, young children, and the elderly. This isn't respect in my country. Young children and the elderly are often given herbs instead of the medicines. And you can see that there is no correlation between age, gender, level of education. The respondents to the first myth correlate with the response to the first and second myth. We see Spearman correlation coefficient from these two questions. Myth 4, the homeopathic remedies work. Chemical drugs manufactured in factory is often opposite to natural drugs such as herbs or homeopathic remedies. The use of homeopathic substances have very long tradition. It was first used by German doctor Heinemann in 1796. And the vast majority of respondents don't have an opinion on this subject. But 20% of response believe in the effectiveness of homeopathic remedies. The obtained results are also confirmed by other studies. According to 26 studies, 40 of Poles use homeopathic preparation. In 2011, in France, every third cancer patient used homeopathic medicine. The respondents show basic gaps in chemical knowledge. Homeopathic preparations are made by rapidly diluting the starting substance and shaking. In this table, we see what concentration are we talking about for homeopathic products. In the first column, we see C-scale. This is a scale used by homeopathics to describe concentration. In the second column, we see the dilution written mathematically. Please pay attention on the right hand side of the table and the exploration described there. So we see that mid-fourth is busted. In clinical trials, no difference was observed between placebo and homeopathic medicines. Comprehensive studies have been published by the Lancet, British Medical Journal, and the European Journal of Cancer. We see some of them on the slide. The only significant correlation found between opinion homeopathic remedies work and opinion all chemicals are harmful and herbs are safer than drugs, but both these correlations are low correlation. If we are talking about medicines, whether chemical or natural, herbs, homeopathic medicines, we must also mention vitamins. Vitamin C is very important to human and must be supplied in the diet because our body don't produce it. But does vitamin C help with a cold, flu? The vast majority of respondents agree with this opinion. It was more than 80% of respondents. But scientific research doesn't support this myth. Vitamin C has an impact on athletes who engage in really hard training and soldiers in a winter condition. It doesn't help normal people in everyday life. On the slide, we see several publications on this topic. Where did myth come from? The origin of the myth dates back to the 1970s. Nobel laureate Linus Pauling was written 3 books on vitamin C. In the first, on the use of vitamin C in flu. He believed the high doses of vitamin C could reduce the incidence by up to 45%. He himself took extremely large doses. It was strange that he didn't poison himself. So, myth 5, vitamin C is commonly believed to protect against cold flu. However, vitamin C doesn't cure flu, nor it is a providence measure against flu. And no correlation, and no correlation with a previous 4 question. Okay. Myth 6, vitamins can be eaten unlimitedly. It is recommended to eat vegetables and fruits rich in vitamins, use dietary supplements containing vitamins, and eating fruit products supplement with vitamins. It isn't too much. In this question, this is only one question out of 19, to which there was majority of respondents answered correctly. We can see that it was almost 75%, but it's also worth exploring. Are people actually not eating too much vitamins. They eat fruits, vegetables, eat foods with added vitamins, and eat dietary supplements. It can be too much together. As we can see in this slide, the effects of the vitamin overdose can be very different, from mild symptoms to severe damage, especially from pregnant. In Poland, this is a serious problem because most pregnant women use vitamins without consulting a doctor. So vitamins cannot be eaten without restriction. Overdosing on vitamins is harmful for us. The only significant correlation would found between opinion vitamins can be eaten unlimitedly and the opinion all chemicals are harmful, all natural substances are healthy, and herbs are safer than medicines. The first of these three correlation is moderate correlation, the other two are low correlation. The second myth is future supplement the topic chemical versus natural, and in Poland the terms brown sugar and cane sugar are synonymous. So sometimes I talk brown sugar, sometimes cane sugar. In the seventh question, most people choose an allergy natural product. Even though in question first and second, they declare that they don't consider all chemical substances to be harmful and all natural substances are useful. Only 14% answer correctly. Unfortunately, most of the respondents were wrong. Both white and cane sugar are produced in the same way in the factory. The only difference is that so-called cane sugar doesn't undergo the last stage refining. Therefore, it contains molassa in its composition. And what is molassa? Molassa is a dark brown thick syrup with a slightly alkaline reaction. It is formed as byproduct during the production of food sugar. It is a product containing about 40% of saccharose, the further recovery of which is unprofitable. In this graph, we can see that 40% of molassa is water, another 38.4% is saccharose, the main component of sugar. The next 21.6% are the other sugars. Sometimes it is said that brown sugar contains micronutrients. Of course, it is true. The graphic shows the number of micronutrients in molassa. Potassium is the most abundant mineral in molassa. The remaining compounds are present in such minimal amounts that our health is not affected. Comparing the properties of white and cane sugar and the price, it seems it's buying cane sugar doesn't pay off. So, white sugar is 2% saccharose. Cane sugar is a mixture of various compounds, mainly saccharose and molassa. Molassa also contains saccharose, water, and other sugars and other chemicals. The amount of minerals in it is very, very small. Three correlations were found between the seventh myth and the myth discussed earlier. Three these correlations are low correlation. The next three myths also apply to food products. Myth H, peanut is so good source of iron. It's a myth, but surprisingly presenting one. The story behind the myth and science that debunks it is fascinating. But the first, iron is an essential micronutrient. Its lack in the human body causes anemia. The symptoms of the anemia are described in this picture. To prevent anemia, you should eat iron-rich foods. Until recently, spinach was contained to be such a dish. As a young children, I had to eat spinach for lunch, both at home and in the kindergarten, and I hate it. For a long time, it was thought that spinach contained many iron compounds. Scientists believe it contains 30 milligrams of iron per 100 grams of leaves. Meanwhile, it turns out to be really only 3 milligrams. It is believed that scientists put the comma wrong, or that they confused the iron content in the dried leaves with that of fresh spinach. Even though spinach doesn't contain much iron and the iron contained is not readily digestible, many people still believe that spinach does contain iron. Over 70% of people believe that spinach is rich in iron. Only 10% don't believe is this myth. Perhaps the myth about the healthy benefits of spinach was confirmed by the fairy tale about both. The downside of spinach in the presence of alkalic aids, which hinders the absorption of valuable elements, calcium, iron, and magnesium. Spinach also contains purines that increase uric acid levels, which is why goat sufferers should avoid spinach. So, myth is busted. Spinach doesn't contain much iron. It is also not healthy. And only 4 correlation was found between this myth and another myth, and 3 these correlation are low correlation. The 9 myth. Don't eat green cucumber and tomato together. It is myth, or it is true. In our kitchen, we often prepare salad to which we add cucumbers and tomatoes together. It is good for our health. In this case, the respondents don't have a clear opinion. We see an equal distribution of the answer. About 30 agree with this opinion or disagree or have no opinion. The slight advantage of the first, I agree, is not statistically significant. And what are the chemists saying? Ascorbiose contained in just 1 teaspoon of cucumber juice destroyed vitamin C in 3 liters of tomato juice. So myth 9 is not myth, it's true. Don't add cucumber to tomato if you don't want vitamin C contained in the tomato. And there is also no correlation with this myth and previously discussed myths. Myth 10. Eating almonds can lead to dehydration poisoning. It was a very popular myth when I was a child. My grandmother wouldn't let me eat more than 6 almonds. And what do people think today? The vast majority of respondents didn't agree, didn't have an opinion on this subject. It is 64.4%. Most people probably don't know that there are 2 varieties of almonds, sweet and bitter. And bitter almonds contain amygdalin, which in the body relates to deadly prussic aids. The bitter almond is slightly broader and shorter than the sweet almonds and contain about 40% of the fixed oil that occurs in sweet almonds. Bitter almonds may yield 4 to 9 milligrams of hydrogen cyanide per almond and contain 42 times higher amounts of cyanide than trace leaves found in sweet almonds. So, eating sweet almonds doesn't pose a health risk, but eating more bitter almonds can even be fatal. Bitter almonds were a tool of execution, including in ancient Egypt, in Roman Empire, and in court of Medici. The culprit ate a bowl of bitter almonds and died in agony. Short but very, very terrible. The only correlation is between the question and using tomato and cucumber together, and it is also low correlation. Myth 11. And now 2 myths about traditional treatment. These are questions about whether it's better to use home traditional methods of treatment or modern drugs from the pharmacy. So myth 11, cabbage wraps help to reduce fever and bruises. This is an old traditional method of treatment. My grandmother also used this method, but it is currently in use. Most of the respondents don't have an opinion on this subject, but we can see that 46% know this method and find it effective. The everyday experience of people of medical research seems to confirm the effectiveness of this method. It can be considered that 11 myth is partially confirmed. Although it isn't known what substance works to reduce the swelling, the use of cabbage leaves makes sense. And 5-week correlation between this myth and the myths previously discussed have been found. Myth 12. Barley from the eye can be cured by rubbing it with a gold ring. Another myth that studies the effectiveness of traditional medicine. This method of treatment was used not only by my grandmothers, but also by my mother and my friends from college. The vast majority of respondents agree with this myth. Many people tried barley on the eye with a gold wedding ring. Almost 50% agree with this opinion. The doctor exploration is simple. Rubbing with gold can help because friction causes heat. In addition, a massage with a wedding ring increased blood flow in the infected area. Better blood simply means your white blood cells will have a better chance of fighting the infection and killing hostile microbes. But equally effective is rubbing the eye with a warm egg or just a warm eye compress. It can be even from tea bags. So, a warm compress is a safer method to remove barriers from the eye. And 7-weakness correlation between this myth and the myths previously discussed have been found. 13 myths. GMO is harmful. We come back to the myths related to food. A genetically modified organism, a GMO, is an organism whose genome has been altered by genetic engineering. The first GMO was created in 1973. In ads and daily newspapers, there is often information that is against the use of GMO. Therefore, most of the respondents agree that GMO is harmful. It is 50%. Only 20% of the respondents are the opposite opinion. However, it is important to remember that humans have changed the genetic makeup of food for thousands of years. In a series of slides, we can compare the appearance of the old, unmodified varieties of fruit or vegetables and their appearance today. So, watermelon, banana, eggplant, carrot, and corn. Other studies saw a total lack of knowledge in humans. 43 of Americans and 63 of Europeans believed that genetically unmodified plants have no genes at all. And for example, people think that tomato with a fish gen has a flavor of fish. This gen was added to tomato to make them more resistant to cold. And 9-way correlation between this myth and the myths previously discussed have been found. Myth 14. Eggs from pastured hens are healthier than eggs from farmed hens. Most of respondents agree with this opinion. However, scientific research showed that there is no difference in eggs composium resulting from the specific breeding system used. Only the feed given to laying hens is important. Eggs we very often use in cooking. This slide shows chemical information about egg. But in Poland we have a problem with free-range eggs. Research has shown that these eggs are heavily contaminated with dioxins, which are formed when based in birth on furnace. And in the research, eggs were found in which the dioxin limit was unchanged 4 times. So scientific research showed the eggs composition depends on the feed provided to the laying hens and not on the way they are reared. And the environmental pollution negatively affects to the composition of eggs from pastured hens. So when we buying eggs, you should answer the question of whether you care about sanitary quality of eggs, eggs quality in terms of input content, hence living comfort, the hen feeding system used. And only a few relationships have been found between this myth and myth discussed previously, and there are low correlation. What time? Okay, maybe. Myth 15: drinking tap water in Poland is unhealthy because tap water contains chemicals and bottled water contains minerals. So the term water has 2 meanings. For chemists, it's a chemical compound consisting only of water molecules. In everyday life, we are talking about a mixture in which, in addition to water molecules, various gases and minerals are dissolved. The tap water is a mixture. There was majority of respondents, 45%, don't agree with this statement, but about 30% agree with this statement and 25% don't have opinion. And the obtained result are contained with the international research. And however, studies show that tap water contains similar amounts of the minerals to mineral water. Myth is busted. Currently, tap water in Poland is healthy and safe. You can drink it without boiling it. But mineral water from plastic bottles may contain harmful bisphenol A and bisphenol C. And only a few relationships have been found between this myth and the myth discussed previously. And summary. I hope I've clarified which myths are true and which are not scientifically, and that I have changed your point of view to some of them. In this picture, we can see correlation between answers, and in red we can see middle correlation, and in blue we can see low correlation and number of correlation between this question. The obtained results show that a large percent of the society doesn't have basic knowledge on this subject. There's no influence of the degree of education or its type on the beliefs of the research participant was noticed. The influence of age and gender and on the beliefs of the respondents was not noticed. Similar results were obtained in 2012 by these authors. The obtained results are a big challenge for people responsible for education, including teachers. The results show that not scientific ideas are widespread among people and resistant to started teaching method. The question then arises: how and what to teach students to become informed citizens who would choose wisely on science and technology? Perhaps this question will be beginning the new research. Maybe the starting point for new research should be the love of Adolf Jost. These loves are very, very old, but I think they are still valid today. Folk wisdom in Proverbs also support this point of view. First love. As time goes on, the power of the elder association weakens more slowly. Love two. Second, in two associations are the equal strange, but one is older than the other, then repeating will favor the older association more. So I think we must make new research and maybe let it together. Thank you for your attention.
Thanks, MAŁGORZATA. It was really very interesting, at least for me. But I hope so for not only for me. Yeah, I have a lot of questions, but okay. First of all, I want to ask at least one question. For example, all of us know very well that we have in schools, for example, let's say teaching and learning content, some programs, doesn't matter which level, for example, or general programs like in Lithuania, and so-called syllabus after general programs. Generally speaking, we have teaching and learning content. I have in mind, of course, science subjects as chemistry, biology, for example. And what do you think about the content? Is it appropriate content in light of your presentation? Because, for example, I believe that we can find in textbooks, for example, that vitamin C is okay. Everything what you said in your presentation, I think a lot of contradictions in the content.
And I looking for our textbooks or our curriculum, but it isn't very information about this topic. Our curriculum and our textbooks for our students are very scientific. There are no information about everyday life. So theory, I looking for this 19 minutes and I don't found a lot of information about the book. So I think it is a big problem from in Poland about this, because our children are learning about, I don't know, very difficult terms and don't learn practical. I don't hear you.
Do you mean that teaching learning content is somehow so academical?
Yes, it's so academical, yes. In chemistry, we don't teaching about vitamins. In biology, it's only one topic about vitamins for 19 years.
And obviously, we have a lot of, let's say, misconceptions somehow. Yeah. My second question. Okay, if you are speaking about, let's say, school secondary level, somehow it's let's say more or less is clear. But what about public, about adults? Because you also mentioned how to have informed citizens or literate, scientifically literate citizens, adults, our society in general, because we know that in public we have a lot of, let's say, incorrectness, misunderstandings, etc., related to what you have said during your presentation.
But I think that it's very difficult to change mind or change opinion of people. So I think we must better educate young people, because if you believe for something, you don't change your mind. So of course.
Yes. I am somehow a chemist, at least my background, but I am buying in shop brown sugar, not white. Okay, colleagues, do you have some more questions to MAŁGORZATA? It's a very interesting topic. And okay, MAŁGORZATA, do you see some ways how to change, let's say, this situation?
My first idea is that we must better educate teacher for primary school or kindergarten, because we have a very big problem in Poland with this. My grandson is better educated for science than his teacher. So, so if we, I think we lost 4 years in kindergarten and then 3 years in elementary school. The children are not good educated in science.
I want to support this idea because it's really approximately the same in Lithuania. We are observing for many years, let's say decades, that the biggest problem, what is related with, let's say, science literacy or scientific literacy, it's starting from kindergarten and primary school. Because, let's say, focus to science, it's relatively low. In different aspects, having in mind content, teaching process, etc., etc. This is, and another thing is, at least from our perspective, from Lithuanian perspective, that majority of teachers, for example, primary school teachers, they are not oriented to science education, let's say, because they do prefer, let's say, social education, humanities, okay, but science, it's only a small part, and it's very, very fragmented, let's say. Despite, for example, that at least in Lithuania, in general programs and in etc., when we are reading programs, it's some impression is that it seems correct, but practically not.
Well, it's problem. I think it's problem in all countries.
And how do research can help in this case? Because we are researchers, and what can you suggest for researchers?
I don't have a clear idea, because when I made this research and then I prepared and I count this all correlation, it is very, for me, surprising. I think that students, young students who is biologists, chemists, mathematics, that then have the other opinions than the older people.
We have one comment.
It's surprising, and I don't know what.
Małgorzata, in conversation window, we have one like a comment, like an opinion from. Can you check?
The solution is ABC from kindergarten to high school. Oh, of course, but if
high school.
But we haven't teacher who can teach in this way. Sometimes I have a workshop for teachers and I teach them how to use IPSE, but it's very small part of teachers who know how to work in this way, and they don't like work in this way.
Yeah, I do agree with you, because, for example, based on our experience in Lithuania, we have every year, starting from 1995, we have National Scientific Practical Conference, Natural Science Education in General School or Comprehensive School, and our scope, let's say, it's quite large, from kindergarten to universities, trying to attract, involve teachers, lecturers, society, NGO, etc. And I can say currently, based on 26-year experience, because we are organizing this conference every year, and this year our conference is typically we have this conference in April, at the end of April every year, but due to pandemic we postponed. Last year it was online, and this year we hope that it will be possible in beginning of October this year to have our 27th conference. But let's say every year we are observing, let's say, only a small part of active teachers from kindergarten teachers, primary school teachers, secondary school teachers. But our focus is mainly on kindergarten and primary school teachers, how to let's say, attract them, how to motivate them to work more, let's say, in this way. Inquiry-based work, practical work with kids, etc., etc. This is absolutely important. But again, I want to say this is only a small part of, let's say, teachers. Majority are not so interested in this. And again, we see next idea. Maybe colleague can comment loudly if you want. We have some minutes for discussion.
Well, I see that we have problem with quality of teachers, yes. And in our country, there is very popular university for children. So it is informal education. In these places, we have good teachers, and they use a lot of good method to teaching. So it's used IPSE. Okay, but it is only for children who which parents have money, because you must pay for it. So we have two ways of education for free. Badly teacher and no IPSE and no good education. And if you have money, you can pay and your children have a good education. But I think it is a problem for a teacher. No, in our country, a teacher don't have money. If you go to gallery and work to a shop, you have more money than you are a teacher. So it is.
Do you? It's like an axiom that good education for each people.
Yes, Yes, but because if you don't pay money a teacher, you don't have a good teachers. It's normal. If I want to earn money, nobody who wants to earn money will be a teacher, because all people know that teacher, it means no money.
Okay, it's some more questions to MAŁGORZATA. It's really interesting. Really impressive. I was impressed because it's interesting presentation. A lot of misunderstandings, a lot of myths, but what is let's say the most problematic, I think, that when okay in school somehow, but after school, after secondary level, when students entering universities, or maybe not only universities, vocational schools, for example, or just continue to work somewhere in the market, yeah, we should somehow reteaching, because teaching is not so easy, and reteaching is very, very difficult. Let's say to clean, let's say, our brain, and to put appropriate and correct information.
Nice. Reteaching is harder. It's difficult.
Okay, I see now more questions and comments. Thanks, MAŁGORZATA, once again for your nice presentation. And we are approaching to our next presenter. Do we have Peter? Oh, yeah, we see Peter. Hello, Peter. What about Bratislava? Please connect your microphone.
Yeah, it's not so hot like yesterday. It's a little bit better. and the center of town is full of cars, what is unusual for the COVID situation, but probably the COVID is behind us. Minimally, a lot of people think this. So it's a very strange start of summer, and holidays are approaching for children. So a lot of rush and a lot of people in the center and in the shop. So it's strange. The COVID strange everything here, and I'm now from my house. So welcome in my house. Probably sometimes also in present. Yeah, we are back. Perfect, we are back.
You can start your presentation. Okay, we see it.
Yeah, good. So I very like the discussion with MAŁGORZATA, and I think this discussion will not stop by this start of presentation, and I hope also we all will discuss during this presentation. No, sorry.
Once again, please share screen.
Yeah, I'm back. Science and technology education developing a global perspective. This is a topic for these 2 days, and I really like this topic. And I would like to discuss about the global perspective, not only from the global like geography, like the countries, different and the educational systems, but also the global in the meaning of biology education, chemistry education, physics education. Most of examples in my presentation will be from physics education, and I am in Comenius University responsible for preparation of future physics teachers, and also I am quite involved in in-service physics teachers preparation. And physics teachers are part of science teachers, so we are doing also a lot of in physics teacher in science teachers education and preparation. And what some people say that is special for me, that I have two daughters, which is normal, but both my daughters are oriented to psychology and schools. So probably I will, you will see in my presentation that there is also a little bit of educational psychology. And this I would like to take as global perspective in the meaning of a holistic way of looking on the pupils and even at the children. So, cognitive processes in the theory of physics education, this is a real topic of my presentation, and it is not necessary to be disrupted on what that is will be cognitive psychology. Not the cognitive psychology was a topic of my PhD students in 2015. And now I hope all we are a little bit further, and the cognitive constructivism is not the best way of education, and now we are at the age of social cognitive social constructivism, because we know that the social experience of our pupils is very important, as MAޅGORZATA already told on the examples of chemistry or biology education and myths about foods and vitamins. Some people, or a lot of people, not some, a lot of people told me or say me that that physics education has a very long tradition. This is old discipline, physics is, and physics education also, and this is very stable. And the best textbooks for physics education are from 1950 probably. And the only way of going to further is to add to physics education or physics textbooks for secondary schools, to add a new research from physics. Sometimes some people say that yes, it must be adjusted to the age or to the possibilities to work with children, but the mechanics of Newton or electromagnetism of Maxwell should be taught in the same way like it was 50 years ago probably. I will try to discuss during the next 40 minutes about that. Yes, to high level it is true. I always say that if too many people say something, that there is good ground somewhere, there must be some good ground somewhere, but also I say that that the educational scientists, what we are at this conference, the scientists of education. Yes, some of us are also scientists in physics or chemistry or biology, but this conference is about physics, about science education. That we should look also at the pupils, not only at the physics, chemistry, biology, environmental science, or general science, but also look at the children and the development of the knowledge about how children learn. And when I was preparing abstract for this conference, I I had in my hand Sawyer, the Cambridge Handbook of Learning Sciences from 2006, and also there is a new edition, I think 2015. But now I think we are even further, and I will try to present a possible way forward at the end of my presentation. Where we was, I hope, but a lot of our colleagues are somewhere in the last decades of 20th century, taking knowledge as a collection of facts about the world and procedures how to solve problems. We can discuss about that knowledge is a collection of facts. Yes, it is. Knowledge is a collection of how to measure, how to take the data, how to process the data, how to solve problems. Probably yes. What's the goal of schooling? At least in physics education, a lot of people say that the goal of schooling is to get these facts and this how to measure, how to take data, how to process data, how to read a graph into the student's head. Yes, students should know a lot of from here. And the teacher know these facts and know how to measure, how to process the data, how to plan an experiment. And the job of teachers is to transmit them to students. Yes, it is. It is clearly teachers should know these facts. Physics teachers should be well educated in the physics education, which physics is a part of preparation of physics teachers. Yes, clearly yes. Simple facts and more complex facts. I very like discussion from MAޅGORZATA from previous presentation. The myth about vitamins is very complex facts and very complex way to examine if vitamin C is in relation with flu or something like this. Is it simple or is it complex, and at what age we should discuss with children? Somebody told that from kindergarten, and I agree. So the definition of what is simple, what is complex, and the proper sequencing of material, every writer of a curriculum or a textbooks should make some sequence of facts which use for the in building and setting the textbook, but in the 20th century it was not generally taken what is simple or what is complex. It was not examined how children learn. It is very new topic. Yes, we had some psychologists very well known like Piaget and other, but still there is a lot of to do in joining the neurosciences and a series of education. Yes, and what is the successful school? Yeah, the successful school is the school where the children know as much as possible of these facts and of these processes, how to measure, how to plan an experiment. This was last decades of 20th century, and what is missing here? What is missing here, and what we now know, even at the conference, that is missing here. What is missing here? Yes, 3 and 2, 5 points. 5 points. What is missing here? what is quite clear for us, which are focused to preparation of future teachers or focused on teaching or educating science at secondary schools or lower and higher secondary schools, or some of us at primary schools. I hope some of us have in mind. Yes, I will not test because we have not a lot of time for this. But I see, I looked at the program of this conference, and Solange told yesterday something very relevant to this. And Teresa and Lukáš is going, I am sure, today afternoon. Also, Karl is at DICE. Today afternoon is going to add some here. What now we should add? Yeah, what do we add? Last 20 years probably the importance of deeper conceptual understanding. The second half of 20th century was as much as possible. Now. Yeah, there is a lot of reasons. One of reasons is Wikipedia or digital encyclopedias. Yes, it's no problem to access knowledge or information. Information is much easier, like knowledge, because knowledge is in a student's head. Information is possible to find, not in small languages like Slovak languages, but the students who know English, German, French language, they can find information, but the deeper conceptual understanding is much more important. We know, like our colleagues from 20, 30 years ago, focusing on learning in addition to teaching. I still see at my colleagues, some of colleagues, that in the preparation of future teachers, they are focusing on how to teach. I think it is normal, but I hope for a lot of us, this is even normal. Teach future teachers or train future teachers in a topic how children learn, not only how to teach students or how to teach pupils, but how pupils are learning. And this is far not only by modeling or by how to say, by only talking, by teacher talk, but what is more important is create learning environments. The atmosphere, the equipment where the children can learn, and the environment which support learning. Every of us, each of us, for each of us is clear that the pupils learn on a prior knowledge. They build on prior knowledge. Constructivisms were known. But what is the prior knowledge? How to catch it and how to build on it? Here are some emerging some new ways of looking. Some of these are knowledge in pieces by DESESA. We are trying to look at this possibility, and this is something like very grain size of knowledge. So knowledge is not Archimedes principle, but Archimedes principle can be taken like a summary of activated, maybe 5, maybe more grain effects knowledges. Yeah, and importance of reflection. Importance of reflection. Probably each of my students, future physics teachers, will say at the exam that almost necessary. Almost every teaching, every lesson, to give a possibility to pupils to reflect, to reflection or to discussion at the end of the lesson. But when we look at the real lesson they give for pupils, very often there is not time. There was not enough time for reflection because there was necessary to say a lot of. But the pupils can read, so it's not necessary everything told. The people can read. Yeah. So we have prepared with my colleague this scheme. I very like this scheme because it is very simple, and in this scheme is quite a lot of. One of idea is big idea. This is probably one lesson or one teaching learning sequence. This is another. This is put to one context. This is put to another context. And how to join the lessons, or how to join in mind, in the student's mind or in the pupil's mind, how to join the lessons or teaching learning sequences. One of possibility, presented mainly by Win Harlan, but presented also by a lot of other people or groups, is big idea behind this. And one teaching learning sequence is always aiming at attention. I don't like the word motivation, because the motivation is very wide term, but aim attention of the people. Here is the teaching learning sequence. This is what we usually from the last decades of 20th century took like teaching learning sequence. Here is the reflection, or a sort of reflection by discussion. The students in general lessons should discuss peer discussion or discussion with teacher. Another sort of reflection is summarizing. It is sometimes good to say the children or the pupils what was the lesson about, what was the physics lesson about, because they can be focused. If they are not, if they are different way of attention, they can lost the main idea. So summarize, and not every knowledge, or even what teachers say cannot be. It is not always all completely true. So some dispute about this can go to another context, another teaching learning sequence. So this was presented in the journal Baltic Science Education, and you can read not much more, but a little bit more. This was editorial, so not long. Yeah. Today, education graduates daily work with complex concepts. Yes, complex, like MAŁGORZATA told today. They cooperate with others, express themselves clearly in both speaking and writing, understand scientific, mathematical, yes, engineering and thinking about how to sell everything, yes, how to say knowledge or products. And they need to learn, need to be able to learn, need to learn is one way of looking, but need to be able. So it is not necessary to learn or to teach pupils everything. It's much not so easy. It's much harder, but much more important to lead the pupils to be able to learn, cooperate, understand, and and some knowledge actually. Yeah, and this is another difference between education of last decades of 20th century and today. Who is responsible? Who is responsible at school? I'm 55, so I was educated in the last decades of 20th century, and even when I started to teach, I was 20 years at secondary school and world school, so secondary school with international program, international baccalaureate program, and we took that teachers are responsible responsible for the results of the children. And when I started in 1988 to be a teacher, I tried to be responsible for learning of every student or every pupil at my school, and I was happy that I had winner of Olympiads and winner of international comparison and very well exams at international IB exams, but I learned that I cannot be, even I would like be, I cannot be responsible for learning of the pupils, because the pupils are very different. They are access to very lot of various information. They are even in Slovakia from very different social situations. The parents are focused very differently. At the secondary school, they are focused on very different way. If somebody would like to be a doctor of medicine, somebody would like to be lawyer, some would be an environmental engineer or environmental scientist. They are very different. So it's much easier. It's not so hard. It just switch in teacher mind to set responsible for learning the pupils. Every pupil who is responsible for all learning is much better, like only follow the teacher's instruction. Yeah, this is the same, and this is a look of complex situations and two complex physics situation. This is black body radiation. If somebody is in physics education are here and cannot see what is about black body radiation, this is just volt ampere characteristics of a filament bulb here, and with students of secondary school, higher secondary school, and even with our future teachers, we make with data, or we process this data to look at the 4 power in black body radiation. Here is here is not picture. This is a magnet falling through a tube where is 1, 2, 3, 4, 5, 6 coils. Yeah. So it was not it was just example, and what some people say that the main research output of physics education theory is that the complex tasks at secondary school could be very useful for education. And another, that digital technologies well used can be, not must be, can be, not automatically, can be very useful for development of physics education, but not only. Yes, this is teacher. We see, yes, teacher will present complex tasks. Teacher will initiate the pupil will use digital technologies, but what is how people learn? And back in Baltic Science Education 2008, this has been proved that this doesn't work. It cannot work, even if we tried. Few decades ago, we tried. Here is a knife entering states, and we prepare instructions, activities, textbooks, lessons, something like this. A lot of, and we are trying to lead our pupils to some normative states prescribed by curriculum or by assessments. Yeah, but much easier and much better is looking not only on instruction, but on thinking and processing how the pupils think. And last month I was focused on scaffolding especially, but this also can be written, yes, only few lines in this topic, and in this topic we continue. Yeah, if we ask what does it a pupil? Because we work with pupils, like physicists work with some equipment, like some electron microscope, like somebody in biology works with microscope. We work with pupils. Yeah, what is it, pupil? I very like this model of Cloninger, model of person, or the yes, temperament, character, and identity. These three parts of a pupil. Yeah, I still say that I'm not going to psychology. I would like we all can present that we are teaching, learning, for example, Archimedes principle, and we are preparing or even teaching, even in the middle of the lesson, we are working something, or pupils are working something about Archimedes principle, or going to grasp or the understanding on the ability to apply Archimedes principle. It's good to at least a little bit have in mind that the special or the particular pupil has its own temperament, which we cannot change. This is biological. This is not possible to change. It's character which we are developing, and which has identity. Which some schools build some identity, and some other schools doesn't build identity. And the character dimensions are here. Yesterday I had also next presentation, next slide, because for the secondary, for the last decades of last century, mainly in Western countries, was optimal organized character. Yes. Oh, yes. High cooperation and high persistence, or self-directed. And now we see that self-transcendence is even very, very important, even in COVID situation. Yes, to build the ideas at the pupils that they are not the only person at the town, at the global, and then somewhere. They look like to a little bit further. And this is even about, for example, Archimedes principle. And yes, Paul Pease yesterday very nicely presented. The article was The Future We Want, but the presentation yesterday was even something like this: process-oriented, holistic, participatory, transformative, and learner-centered education for environmental study, for example, which is even part of chemistry, biology, or generally science education. I really liked yesterday's presentation of Paul, and I think this is very relevant even at my presentation. We would like to make creative people. What does it mean, creativity? Is generation of product that is judged to be a novel and also appropriate, useful, valuable. By who? By somebody. At least the peers, at the classmates. Yeah. So the pupil must be a member of a team, of a social group where his or her learning takes place. This also was not so general or not was so generally taken as true in the last decades of previous century. Sometimes is a summarizing of this what I told today. Physics teacher should be teacher of physics and also teacher of pupils. And I can see at my students at the university, future physics teachers, that is quite different. Some of them are more teacher of physics, and some of them are more teacher of pupils. And we try to adjust, every physics teacher has a firm, good knowledge in physics, and also to be able to interact with pupils. Next few minutes, just one idea. Pupil must do what they want, at least sometimes. At least sometimes. Read the words as they are written. People must, not pupils may. Yeah, they must. If the pupil do what she or he want, this is a little bit about motivation, yes, about focusing. But the teacher can prepare some education, some environment for this, and in this idea, with my colleagues, we have prepared a few researches. One of this is at the age of 12, a project, eight lessons project, which comprises science, engineering, design, and how to sell the product, and this was published here. And yesterday discussed something very relevant or very similar to this. As I looked, then physics experiment by the student. We can discuss how many of us at preparation of future physics teachers or just teaching at the secondary schools lead students to prepare or to plan experiment. Just for example, you have such magnets and plan any experiments where you will use this magnet and everything what you have in this lab, on everything what can you bring to the lab, and just plan an experiment, and when it's planned, the teacher must look at it because it must be safe, because we can process only safe experiments later, but plan, then it will be checked, and then even take a data and process the data. Something was presented in an article at some conference in March. And general idea behind this is scaffolding, what was presented with my student even in another publication. One example about how students plan their experiments. This was age 14, and the students should plan an experiment with a force meter, sensor of force, and the students plan experiment that they looked for dependence between the angle of the slope and the force necessary to keep something at rest. And they put a hypothesis that this is direct relation. Yes, higher angle, higher force. No problem. At the age of 14, it depends on how the mathematics education is developed at this age, but at Slovakia it was completely normal, even with the curriculum. What was very nice that even they proved it to be true. Yeah, this is the angle, this is the force, and there is direct proportionality. Yes, they discuss something here at the point 0,0 that yes, that it was something not precise enough, but yes, it was proved. And where was a problem? The students well-planned experiment, they well-planned dependent and independent variable, they well-told and hypothesis. Well, at the age of 14, supported this hypothesis by their knowledge, and they proved it. Yeah. The only problem, which some future teachers say, that is overall generalization. That they in the answer they didn't told that it is only from 0 to 30 or 35 degrees, and if they would continue, they would see that the direct proportionality there is not this red. Yeah. How to discuss with students, with pupils, or what the teacher can do, how the teacher can support the students, the pupils, when the knowledge is or the abilities are necessary are higher than is possible, or there is the zone of proximal development of well known. Yeah, so we can support metacognitive activities and affect and cognitive activities. We can direction of maintenance, cognitive structuring, reduction of degrees of freedom, recruitment, and frustration control. This we can scaffold, and how we can scaffold it: feeding back, hints, instruction, explaining, modeling, and questioning. Quite simple results of research of Van der Poel colleague and presented in this article with my student. The experiments planned by students is not necessarily must be complex, because the students sometimes like to setting a very challenging research question, and here is one example. I like quite challenge question was this is a gum or how to say from stationery, and they are they try to find the dependence between the force at which it was prolonged and the maximum height to which it flowed. And the problem was how to measure the force. and the pupils find, or how to say, invent at the social growth of peers at the class. It was new for the class, new for the peers. How to measure the force? Just use the force meter, prolonged it, and another students took scissors and just cut the small string here, so they was able to read the force just at the moment when this has been released, the rubber band. Yeah, so this is how we try to look how the pupils learn. Yeah, the teacher was just allowing the pupils to do what they want. Yes, they had some structure how to plan the experiment, and this was one step when they of this planning. Here is another example of a problem stated by pupils, initiated by pupils, and with the help of scaffolding by teacher developed. The question was, here is a water, and the question was to find the dependence of the boiling point of water, how it's depend on the pressure. So this is a vacuum something for kitchen, and here is a pressure sensor, here is a temperature sensor, here is the water, and we were able to lower the pressure inside. The pupils was able. It was 17 at the age of 17. Lower the pressure, measure the pressure, and look if the water is boiling, and measure the temperature simultaneously. So if you can imagine university students, future physics teachers, to individually plan their own physics experiments in a role of secondary schools, question yes or question no. If yes, probably we are from educational system where it's normal to plan to let pupils plan the experiment. In baccalaureate, it is a necessity for final matura exam, and if not, we can discuss in some other articles about if this is necessary, and if yes, how to lead future teachers to be able to do. Yeah, so we have 2 minutes where we can go later. We can go later than in science education, in physics, chemistry, biology, or environmental studies education. We can try to use not the traditional like electromagnetism, radioactivity, optics, this classification of topics, but it seems to be fruitful to look at symbols, patterns, order, categories, and relations. It seems that every knowledge can be split between these five points, and it seems that the student thinking is related more to these points, like to traditional context, dividing like optics or electromagnetism, or we have a lot of to teach in physics. We have a lot of to teach, and we have very limited time. And sometimes it's seen that even mathematics is built from 3 months of the age to the adult. And if we miss some stage, or the pupil miss some stage, that at some stage 2-3 years is not well educated somewhere or in some of these 5 points, it's very hard to replace, to continue with such person. So this is just an idea, and thank for your attention, and I hope we can cooperate further, even probably by international project. I think in November there is a possibility to apply for a European project for teacher education development, so we can probably continue, because I found this conference and the group about Vincentas and Journal of Baltic Science Education as like very strong group. So thanks.
Thanks, Peter. It's really nice. I do not see questions from colleagues. Maybe my first question, if possible. You mentioned this is very interesting also concept, not only learning, but students or kids or pupils, as you said, able to learn or to be able to learn. And I have in mind not only, let's say, simple abilities, but let's say capacities to learn something, because we know that some students, some kids have not so good capacities in general to learn, and this is maybe different approach, and what do you think?
Clearly the capacity of children, of every children, or capacity of mind is very limited. It's not the mind or the brain has fairly not unlimited capacity, and it was presented, or I tried to present it in my presentation at few stages. One stage was that the pupil should be led to be responsible for the learning. So if the pupil is led to be responsible for the learning, he's making some synchronous education, or the adding to new information, or developing of new abilities, or reading or just rereading of some pages of a textbook or other information by his or her own, and this help her or him to not be overloaded by information which is not able to grasp. In the last century, when a lot of schools was set in a situation that for the age of 14, it is normal to be able, and there was a huge list of knowledge, and sometimes what was better, even list of abilities. It's not usual. Usually list of knowledge, what the student should be able to know, and this led some pupil to be not enough educated, because their capacity was much higher, or the interest what was in particular topic or particular school subject, and other was overcrowded because or overloaded by the information, because they were not able to grasp it, not able to connect it to our previous experiences, or not able to be connected to previous to the experiences from home or from community. And now seems to be this is very new. This is very new by one colleague, 5 Pillars of Mind. A book is called that if we split the science subjects or science topics here, that even even at biology education, the student can be very well developed in physics topics, because in biology is a lot of symbols, a lot of patterns. For example, there is an order, there is categories, there are relations, and even back in physics topics like I don't know, Ohm's law or electric current. Even we can develop symbols, patterns, order, categories, relations, and if we prepare or adjust the concepts or the context of the textbooks in this some of this, then I think the cognitive load is much lowering. So I hope to lower the cognitive load of the pupils. Yeah, and even the same at in physics teacher preparation, the scheme I was presented here and in 2018 in Baltic Science Education. This one scheme for development of teaching lesson or development of activity for a pupils or series of activities. This was made by Stenberg Cognitive Psychology and a lot of other works. It was written on 50 pages by my students, and I think it is enough to present this one page and discuss about it. I think it is very lowering the cognitive load for future or even for the in-service teacher training. Yeah. Microphone.
Yeah. Thanks, Peter. Lucas wants to ask, please.
Oh, yes. First, thanks a lot for an interesting presentation. And you said that you are preparing future physics teachers, which we have in common. What is their feedback on those activities, ideas, and do you have some feedback whether they keep them in their practice when they come out from the university, and probably give you some feedback later on?
Yeah. Look, probably you mean the experiment planned by the by the students. Yeah, the experiment planned by the pupil. In the interbaccalaureate organization, we use it for more than 20 years, and when we started 20 years ago, it was very hard to implement it to schools all over the world, because for many teachers it was very strange, and they try to some of them very help the students, even plan, even here you have a plan and write it in your words, what is not prepared or planned by the pupil. And another was that you should plan something, so plan, but it's not so easy, because there is the students should get the rubric for helping him to make a tick which what part or what stages he went through, and now we are applying it at the second year of. Future physics teachers are prepared for 5 years, and we implement it to the second year. And this is first subject oriented to physics education. In the first year of study, they have some physics, mechanics, electromagnetism. They have general psychology. We try to make it like education psychology, but it's hard to find a teacher for educational psychology, they have a course of general psychology, and in the second year we implement it, and this is 2 months. This is 2 months, so this is six lessons, 6 weeks. When we firstly present some, then discuss, then they prepare something for formative assessment, and the final they should prepare in the role of secondary school student their own experiment for summative assessment. And it is firstly they take it like something very strange. At the beginning, in 2-3 weeks, they take it, yes, it is good, it is interesting, and it developed the pupils. And about 2 years, in the 4th year of their study, they are able to remember even details of their plans. So they see that it is much deeper learning, even for them. How to solve a problem, how to say a problem. We sometimes say that the scientists, the general science, physics, I don't know, physics of particle physics, the most important is to formulate the question. So we say that even at the secondary school, we try to devote few lessons to the abilities, to development abilities, to formulate the question. So.
Yeah, thank you. I think it's important. Thank you.
For question. Yes, thank you.
Thanks, colleague. Some more questions, maybe before coffee. No, no more questions. Maybe. Okay, colleagues, we finished successfully our second plenary meeting with 2 presentations, with 2 really nice and rich presentations, and I hope that we can learn a lot from them. And now we have half an hour coffee break, and we will meet again at 12:30 for session 2. And I hope that also our session will be successful.